We'll talk about the DICOM protocol, how it is connected with medical imaging, and then we will discuss the results of my research. First of all, let me introduce myself. I'm a student at Tomsk State University, and currently I'm working at Bison company. And also I'm participant of a research group, AISEC team. Now about my team. AISEC team is a group of enthusiasts, and the main goal of our researchers is cybersecurity of machine learning and artificial intelligence implementations. There are some links to our projects. The first link to the project, which about I will talk today, and the second link is a projects link where you can find other researchers from our team. Okay, let's start. Everybody knows that nowadays machine learning evolves very quickly, and one of the most popular applications for machine learning is medical imaging. Medical imaging is an area where neural nets are used to detect tumors, to identify some different diseases and so on, and all is based on X-rays, MRI scans and stuff like that. Data scientists use sets of medical scans to train their networks. These scans are represented in the DICOM format. For medical imaging, data scientists build a huge machine learning pipeline, which includes ML models, converters, DICOM readers, and so on. And while researching the security of medical imaging, we chose not the ML models themselves, but we chose the readers and the converters and tools for working with the DICOM protocol. And after that, we started researching the DICOM protocol in general. And what is DICOM? Or DICOM, or Digital Imaging and Communication in Medicine. It is a data format protocol exchanging between various components. And generally speaking, DICOM has two parts. A file format of medical scan. It describes how scan information is stored in a file, and a network protocol, which describes communication between two devices for transferring DICOM file. At the beginning, I will speak about DICOM file format and how it is connected with medical imaging, and then I will tell about network protocol a little. Why it is interesting to test DICOM parsers for vulnerabilities? All vulnerabilities can influence the whole pipeline, machine learning pipeline, and its result. For example, some ML model is diagnosing some scan for lung cancer. And if an attacker exploits any component in a pipeline, for example, a simple dose of DICOM parser, the model will give a wrong result. And that's why it is interesting to search for vulnerabilities. NVIDIA Clara. NVIDIA Clara is the most popular machine learning pipeline that deals with medical imaging. Clara Medical Imaging provides developers a set of tools to create medical imaging workflows. And it takes DICOM files as input data. And the model which parses DICOM file in NVIDIA Clara is DICOM Reader. DICOM Reader is a Docker container. You can download this container from the official site. And if you look inside, we can see a Python source code. And as we see, it uses the SimpleTK library for DICOM reading. I used American Fuzzy Loop for finding weaknesses in SimpleTK library, and after fuzzing for a couple of days, we finally got a crash that was caused by a heap buffer overflow. And actually, there is a fun story about reporting this bug to the vendor. In reply to our report, the vendor answered me that it is not a bug in the library. It is a bug in our DICOM file, that one we attached to prove the existence of this bug. And they kindly fixed our proof of concept DICOM file and sent it back to us. And fortunately, this story was ended with a happy end. The misunderstanding was resolved, and the bug was fixed in a few days. And another bug which I found in a simple ATK is a classic buffer overflow in patient name attribute. As we see, memory for the patient name is located on the stack, and then the name from the file is copied there without any length limitations. And what we need to do to trigger buffer overflow, we just need to create a DICOM file with patient name longer than 512 bytes, and after feeding this file to DICOM parser, it will crashed with core dump error. And these simple steps are enough to crash in the entire medical imaging pipeline. Okay. The next vendor which we chose for security testing is RTank. NVIDIA Clara recommends this for input data management. Because it has a web interface and it makes data management more easy. You just need to have a web browser. And RTank is a standalone DICOM server, which is easy to use. Also, RTank is widely open for developers. It provides REST API for writing different plugins. Official site says that a lot of medical universities and hospitals also use RTank already. And on this slide, you can see the statistics of RTank. There are servers which is running on the internet, and it is popular in America and Europe, as we see. And this statistic is made with a Grinder framework. This framework is really cool. I will share information about it at the end of my talk. Okay, to start talking about RTank, let's talk about RTank REST API. On this slide, you can see a list of API methods, for example, shutdown methods and reset methods. And also, I think that the most attractive methods for an attacker, they execute script methods. RTank is open source project, so we can go to the source code to find out what this method does. It turns out that this method does exactly what it says. It takes in a script in Lua and executes it without any validation. On this slide, you can see an example of a request with shell command for creating directory. Okay, it will be a disaster if not the fact that RTank has authentication. Unfortunately, this authentication is disabled by default when you use RTank from the official site. It is enabled in the official Docker image, and it will be okay if not one problem. If not one problem, that RTank authentication doesn't have any CSRF prevention. You can see an example of a CSRF payload, which sends an arbitrary shell command to the server. And in a short words, the attack scenario is as follows. You host this HTML on your web page and send the link to an RTank user. And once he opens the link, his browser will send an authenticated request to execute an arbitrary shell command. Okay, of course, I immediately reported this bug to the vendor, that your server doesn't have any CSRF prevention, and considering your insecure API, it may lead to some serious consequences. A maintainer of RTank answered me that RTank is a microservice, and you need to create a security environment by yourself. And furthermore, RTank documentation already has warnings about CSRF. Okay, yes, RTank documentation warns us about CSRF, but I still was a little suspicious about it. And I decided to view RTank documentation in the Google Cache. And yes, here it goes. The documentation didn't have any CSRF warnings just a few days before our report. I think it was a little strange of vendors' reaction to vulnerabilities. Um, to sum up, Artank has authentication, but you need to create your own authentication mechanism. And as far as understood, Artank doesn't care about confidentiality of sensitive data which is stored in it. And I wanted to once again highlight that each DICOM file has personal data about patient, like name, sex, age, and medical survey. Okay, let's move on. The next vendor which we chose for testing is DCMTK. DCMTK is the first implementation of the DICOM protocol. The development of this toolkit was started in 1993 with the development of protocol specification. And NVIDIA Clara recommends to use DCMTK in their workflows. And also Artank use the DICOM server from DCMTK as its core. Also, I used parsers like AFL and libparser to search for weaknesses in DICOM parsers. It has found several doses in different parsers of DICOM format. And also, we discovered that one of the parsers from DCMTK is vulnerable to XXE attack. You just need to create XML file with external entity, and the example you can see on this slide. And after feeding this file to the parser, the resulting file will contain of, for example, etc passwd file. Okay, I reported this back to the vendor, and the vendor asked me that he can't reproduce this bug on his machine. And to figure out why, I'm going to speak about libxml library a little deeper. Sorry for that, but I think it is important to know. Okay, DCMTK uses libxml for reading XML files. There is an Avast page where you can find some information about XXE prevention when you use libxml library. Also, it says that from version 2.9 of libxml library, the functionality of external entities has been disabled by default. And also, it warns us about its dangerous options, such as XML parse node and XML parse DTD load. These options may lead to a vulnerability if you use these options with these functions from this list. Okay, DCMTK indeed doesn't use these options for XML reading. We continued to dive deeper into researching this problem, and it turned out that libxml version, our libxml version, were different. The vendor had a 2.9.1 version, and I had a later version. Okay, on this slide you can see the final fix of this bug, and as we see, the solution was simply to change XML substitute entity's default argument from 1 to 0. And let's see what this function does. These functions just changes some global variable of XML parser. And here, the lines from 2.9.1 libxml source code, the ones that vendor had on his machine. And as we see, this variable is used in XML parse initialization. And what happened next in the next version of libxml library? Now it appends a danger option XML parse node to parser options, and it allows the external entities in XML files to work. So that is why XXE payload was working on my machine and not working on vendor's machine. And I suppose that IWASP doesn't have a full information about XXE prevention when you use libxml library. If IWASP contained a note about this function, we wouldn't be so confused. Okay, yeah, that is all about my little investigation of libxml source code. And by the way, the XML to DCM parser, which was vulnerable to XXE attack, also has functionality of reading any local files. The idea is the same as with XXE. You just create a file with tag pixel data and put the name of local file, and the result will, and in the resulting file you will see the etc password contents, for example. And also this parser doesn't have any keys or parameters to disable this functionality, and vendor doesn't consider this a vulnerability. Okay, let's move on to the network. DICOM protocol describes the communication between two devices. Usually it is used between database, aka DICOM server, and a scan machine, and also between database and the device where a doctor can analyze the survey. There are common methods of DICOM protocol. The echo method, the echo command is used to test the connection between two devices. The find method is used to search a scan. The get and move methods are used to retrieve image from the DICOM server. And the store method is used to store image on the remote DICOM server. The most of DICOM servers are configured in such a way that anyone can establish a connection with them. It is pretty simple to retrieve images from a remote DICOM server. It can be accomplished in just two commands. You need to know a host and a port of a remote DICOM server, and another thing which you should know is application entity title. What is application entity title? Application entity title is an option of DICOM server. It is used to create some kind of user access. For example, different PAX systems use a one DICOM server. And to set up a different storages, you should use application entity title. It is just a word. And it kindly identifies a user or PAX system to DICOM server. But this identification doesn't work because all PAX systems use default application entities, and you can just brute force this application entity. And after successful brute forcing of application entity, you can establish a connection with a DICOM server and download a full list of patients by this command, which you see on the slide. And then you pick a specific patient whose server you want to download, and you create a request with getS2 command with a patient name, and by this command from the slide you will download the patient's full survey, and that's it. Okay, here is a statistics of DICOM servers on the internet. An interesting fact that it became more popular in the last year. In 2019, there were about 1,000 hosts, and in 2020, it increased by 2. Okay. As I was focused more on the problems of implementations, I tried to fuzz DICOM network protocol implementation, and I used FLNet for fuzzing. It is pretty simple to expand the FLNet fuzzer. You just need to add two functions for parsing input data and for retrieving a status code from service response. And I have added DICOM protocol to the FLNet repository, and there is a link where you can read a tutorial of how to use the FLNet to fuzz DICOM protocol, and how I expanded FLNet for DICOM. Here is the structure of the DICOM packet, and I used PDU type as a response code, and the parsing of input data was based on PDU length. And here are the first results of fuzzing the DICOM server from the DCMTK. I have found a few doses, and all these doses were reported to DCMTK. Okay, now I want to summarize my talk. I will state several points. The DICOM operates on sensitive data, such as personal info and medical service, and default configurations allows anyone to retrieve this data. The DICOM tools contain basic vulnerabilities like CSF, XXE, insecure functionality which allows you to execute a code on a remote machine, and also buffer overflows, heap buffer overflows, and a lot of doses. And all of these vulnerabilities can influence the whole machine learning pipeline and its result. And I think that the DICOM community and vendors mostly pay little attention to the confidentiality and security of their services. And before finishing my talk, I'd like to say that my friend Antony Nikolaev will speak about his Grinder framework at Bulkhead Asia 2020. I used this framework in my research to grab statistics, but this framework can do a lot of cool things too. Please check it out, and thank you for your attention, and I'm ready to answer the questions.
Okay, thank you, Maria. We've got one question, and that is, has there been any malware seen in the wild that targets vulnerabilities in DICOM?
I didn't scan a vault for medical pipelines, medical imaging pipelines, and so I don't know.
Okay, fair enough. One question that I just had was, you showed that the amount of DICOM servers had gone up by to over 2,700, but those are all accessible on the internet. Like
yes,
on...
we this framework uses a Shodan database for scanning, and it takes all the DICOM servers from Shodan database and rescan this service. And now all 2,700 servers are available on the internet, and also some interesting fact that about 700 of these servers allows to connect to them without any application entity title, and you just you just can go and to take images, and that's it.
Wow. Okay, that sounds bad, but that's just me.
Yes.
The other question I had is, you mentioned an XXE bug, and you contacted the vendor who said, I can't reproduce it on my machine. You could. Was there ever a fix applied where the new updated library was included in that vendor's product?
This version is included in products, any products? I didn't understand a question.
You mentioned that the libxml from a newer version by default doesn't do XXE anymore. But
yes,
you did a test and found that, at least from the software itself, no protection is given. So they are, if the XXE is not exploitable, that would be entirely because the library itself doesn't allow it anymore. So my question then is, did the vendor update the library that they shipped with the product? Do you know?
Okay. Did okay? They update this version, but when they each product is linking with libxml, the version of libxml library is different, and they updated this. On my machine, the version of libxml was newer than on vendor's machine. But on different machines, this product can use different libxml versions.
Oh, right. Yeah, yikes. Okay, so that's all the questions that our lovely people found for you. Thank you very much, Maria, for your talk.